This notebook will investigate different ways of plotting your data and acquiring all the information you need from it. We are going to use two powerful libraries for this, matplotlib and seaborn. The data we are going to use is the iris dataset. It is a very famous dataset in the machine learning community, and it is very easy to find. First, let's load the libraries we need. NumPy for numerical computing, matplotlib for plotting graphs, pandas for data analysis, and finally seaborn for statistical data visualization. Now let us load the dataset. As we want to investigate our plotting options, we are not going to do any data transformations, and we will try to see what can we deduct from the data just by looking at the plots. Before plotting, we need to know the data types of the columns. Using the dtypes attribute, we can see the data types of the columns. Another solution and most familiar among data scientists is to use the info method. We see that the ID column is not needed for our analysis. We can drop it using the drop method. Also, we can see that the species column is a string, and that means that this value will be our categorical feature. For our first analysis, let's do a scatter plot of the sepal length and sepal width features. We can do this using the scatter method of the plot attribute of the df object. We can also add a title to the plot using the title method of the plt object. It would be nice to add labels to the x and y axis using the xLabel and iLabel methods of the plt object. Although we can see the values plotted on the graph, it is not very clear which data point belongs to a specific species. We can add a color to each point based on the species column. Let's use the seaborn library for this. We can do this using the lmplot method of the SNS object. The iris setosa species is clearly separated from the other two species. We can also see that the iris versicolor and iris virginica species are very close to each other. We can also see that the sepal length and sepal width features are not very good for classifying the species column. Let's try to plot the pedal length and pedal width features. It is clear now that the pedal length and pedal width features are much better for classifying the species column. There we have it. Just using a simple tool as a scatter plot, we can see that the three different flower species are clearly separated by their pedal length and width. Another plot we can use is the histogram. Let's plot the sepal length feature. A histogram is a plot that lets you discover and show the underlying frequency distribution shape of a set of continuous data. We can see that the sepal length feature is somehow normally distributed. This means that the data is symmetrical around the mean. Seaborn offers a more advanced histogram plot. Let's plot the sepal length feature using the displot method of the SNS object. Something more advanced, but with great statistical value, is the box plot. Let's plot the sepal length feature using the box plot method. A box plot is a way of statistically representing the distribution of the data through their quartiles. We can see that the iris setosa species has the smallest sepal length values. We can also see that the iris versicolor and iris virginica species have similar sepal length values. Another quite similar plot is the violin plot. Let's plot the sepal length feature using the violin plot method. A violin plot is a combination of a box plot and a kernel density plot. We can see that the iris setosa species has the smallest sepal length values, and also its values are more concentrated in contrast to the other two species, where their values are more spread out. Finally, as our data size is not so big, we could have used from the beginning the pair plot method to plot all the features against each other. Let's do this. We see now in one plot a ton of useful information. We can see that the iris setosa species is clearly separated from the other two species by every feature in the dataset. This kind of plot is very useful when we have a lot of features, and we want to see how they are related to each other. But keep in mind that can be slow sometimes. To summarize, we have seen how to plot a scatter plot, a histogram, a box plot, a violin plot, and a pair plot. We have also seen how to add a title, labels to the X and Y axis, and a legend to the plot. Plotting is a powerful tool for data analysis, and we have just scratched the surface. I hope you enjoyed this tutorial, and I hope you learned something new. If you have any questions or suggestions, please leave a comment. Thank you for the time and see you in the next tutorial.